Alright, so this is the problem from the worksheet. And the first question is to label the acid and the base. So I can see that this one's going to be the acid and this one will be the base. So something that stood out to me was this charge right here. In class we learned that that's a red flag, to always look at charge. So we can see that this negative charge here probably means that it's going to be a nucleophile, so it's going to try to attack a proton from this nitrogen. So it's going to be a source of electrons. So yeah. And then the next question is to draw the curved arrows. So since that one is the nucleophile, we know that the arrows are going to be sourced here, and then they're going to point to this hydrogen, and the electrons used here are going to go to the nitrogen. So after realizing that, we can draw the products to show the proton transfer in this reaction. And then the products that we get are there are 2 lone pairs on the nitrogen, so it has a negative formal charge, and then those, and then plus this one, so, and then this one's bonded to a hydrogen. Alright, and then there's a group here. Alright, so that's the product that we get. And then we can draw in the names. So this one's going to be a conjugate base. This is going to be the conjugate acid, because since we know this is the base, so this one has to be the conjugate acid, and then this is the acid, so this one has to be the conjugate base. And now we have to ID the strong acid, strong base, weak acid, weak base. So in order to do that, I'm going to compare the bases. So this conjugate base, when we look at REO and we're looking at the A, we can see that this atom right here, we can focus on that atom, and then this one. And we know that this selenium is going to be bigger than the nitrogen, and that means that it's going to be able to stabilize or spread out the electrons more evenly, or with more stability than this nitrogen right here. So that means that this one is going to be a weaker base, and then this one's going to be a stronger base. So if this one is a weaker base, then this one has to be a stronger acid. And then if this one's a stronger base, then this one has to be a weak acid. So I'm just going to write in, and then weak base, and then strong acid, and then strong base. So when we look at the pKa value, we know that this one's going to have a greater pKa value, and then this one's going to have a lower pKa value because it's a stronger acid. So when we compare the pKa values, we know that the reaction will shift towards the larger or the higher pKa value. So the reaction will shift to the left, or the equilibrium will shift to the left. So that means that the reactants are going to be favored in this reaction. And if the equilibrium favors the weaker acid, then that means that we're going to have more reactants. So we're going to have more of these two instead of these two. So yeah.